G'day Bifrosters. I have a blank slate in front of me. Yeah, I've been fighting with this all day. Maybe I've been procrastinating all day. I've probably been procrastinating all day. That's possibly a better way to put it. But what we're going to have a look at tonight is a very general overview. Hopefully it won't take too long. This is a visual programming thing. See? Visual programming framework even. So we're going to talk a little bit about programming. Really the subject of tonight's video is custom nodes and how to make them. I've just been working on a custom node where I'm doing all kinds of cool things with arrays, and then I realized after I had a look in here, this is the way I work. I tend to lay things out and do it once or twice and then try and do a video of it, which I usually have to do 3 or 4 times. So by the time I actually make the video, I'm quite good at it. It's good, really. It just takes a bit of time. But just for example, this is what it takes to get a median value out of an array. In fact, this plus this stuff and then loops and yeah. So what I thought, instead of that was the original idea for tonight's video, I was taking you through that, but I ran into something that might be a better thing to show you, which is, let's just really quickly, if I throw down a value and I make that value 10 and I copy it a few times, we'll leave one 10 and we'll make one 12, we'll make another one 74. I can compare these values, you see. So I can say, like, are these guys equal? I can pop that out into there and I'll just throw on a watch point. And that's not actually going out to Maya, so it's not going to give me a result. So we'll just quickly do something that'll give us a result, eh? So we'll throw down an F node and just use it as a condition. And when it connects for me, and what we'll do with this condition is I'll just put down a sphere. Always do that. A mesh sphere, like that, and a mesh cube, like that. And so if this is true, let's output a sphere, and if it's false, let's output a cube, and then we'll just pop this out here. And it doesn't like that because it wants a boolean, so we'll delete that port, pop that out there. So right now it's giving us a sphere, which is true. These numbers are equal. Lovely. What happens if I plug this one into here? It turns into a cube, which means it's the false case. It's not equal. And we can see that because that is the number 10 and that is the number 12. I can plug in 74 and 12 and I'm still going to get my cube. So until I plug in 2 numbers that are equal here, I'm going to get a false result, which is great. When I was running through that array example, which I thought would be a simple example for everybody to take a look at, I ran into a situation while trying to work out a way to count all of the positions and calculate a mode for the array, which is just the number that appears the most times, where I could not compare vectors, because as far as I know that's not quite supported. So if I throw a value down and I make that a vector 3, there we go. I'll pop another one down and we'll just change it a bit. 17 minus 225. Now, because our brains work better than computers do, we can look at those and say they're not equal. But I went to plug that in. The first thing I noticed is that I get an error. I can't go inside that. It's a base node. There's nothing in there to play with. So I ran into this before, where I was doing something like when I was first learning how to use Bifrost about 2 months ago. I ran into this and I popped it on the Bifrost Forum, which is a really good place to go, and I'll put a link to that at the bottom of the video. Really good place to go to ask some awesome people how to do things. And what came back from that inquiry that I made was that vectors aren't supported for equals yet. So I was doing a find all in array, actually. Find all in array. There we go. This is also not supported by vectors. So I ended up making my own. It's custom find an array which does take vectors. And all it does is it goes through the array and checks to see if the thing coming in is equal across all three. So we're going to recreate that for now. It could be the case that I'm missing something here, and the Bifrost dev team are going to message me on the Slack channel and call me an idiot, and that's fine. I'm fully aware that I'm an idiot and floating around in the void trying to find things to do, and sometimes I do things that have already been done a lot. But this is just a really good way to show you guys that unlike something like Houdini, which has visual coding in the form of VOPs, it also has coding in the form of X. Bifrost is just visual coding, which means that anything that you can program, you can code in Bifrost. I don't want to take it on because I'm not a good enough coder, but you could rewrite Minecraft in Bifrost if you wanted to. It would be terribly slow to run, but I'm pretty sure you could do it. Okay, what you need to know to learn to code is what a variable is, what a loop is, what a condition is. That's the foundation. Everything else can be built on from there. So what we'll do today is some coding, some visual coding. So we're going to really quickly write a new compound, and we'll call it vector is equal. So this is going to take two vectors. We'll use these two vectors. We'll give them a rename, vector 1 and vector 2. So probably the easiest way to do this is we'll break this down to its scalar floating points, so its floats, and we'll compare those. And then, because this is also serving as a little bit of introduction to programming logic, we'll make a comparison to see if they're all equal. Okay? So the first thing we can do is so we'll put down an equal node. Is x1, so this is vector 1, x. This is vector 2, x. So from now on I'll just call it x1, x2, y1, y2. Is x1 equal to x2? And we're going to set that up for all three. These are our main queries. So is y1 equal to y2? And is z1 equal to z2? So that right now I'm sitting here looking at three true or false statements. X equals y. No, that's not quite right. X is equal. True or false. And over here we can y is equal and z is equal. So for these two vectors coming in to be equal to one another, all three of their components have to be equal. So this has to be true, this has to be true, and this has to be true. So the key word in there is and. If x is equal and y is equal, so this will return true if both of these inputs are true, or both of these inputs are true, so these outputs here. If any of them are false, one of them is false, or both of them are false, it'll return false. So we've just compared these two, which are comparing the x and the y. Then we're going to just add the z onto it. Put another and. So if x and y are equal to each other, and z is equal to each other, and the z's are equal to each other. So this is saying the x's are equal, true. The y's are equal, true. Then this would be true. So the x's and the y's are equal if that's true. Well, that's true if the x's and the y's are equal. If the x's and the y's are equal and the z's are equal, then that is true. And this is our result. So we'll just name that x's and y's are equal. And in here, oops, And in here, x's and y's and z's are equal. So what we've got now is a true or false coming out that will tell us if these two vectors are equal. And we'll go back and go through the logic before the end of the video, but we can now plug this into here and it's going to strictly stay a cube. If I just copy this guy, my 17, I'll just delete this one, 117 minus 25, and plug that in, that's now true. That's now saying that these two vectors are equal, which is a bit of functionality that I can't find in Bifrost, and so I'm making it myself. Now this whole thing applies to all of Bifrost. Bifrost is a coding language. It looks like VOPs. It kind of works like VOPs. It's got its own flavor, and it's definitely its own thing. I mean, there's absolutely no point making comparisons to Houdini just because Houdini does this as well. I mean, ICE did this, and this is based on ICE, but it's not the same as ICE. But it is a coding language. So doing a little bit of logic like that is absolutely and totally possible and welcomed, and you can build on that. You can build on that to say, I need to find everything within this huge list of positions that are within a certain distance of each other. Yeah. So that for that example, you would just use find points in radius and then run it through the entire array of points. If you stop thinking of Bifrost as nodes that connect together and start thinking it as a system of logic, then it's going to get a lot easier to understand. That's what I found for me. Approaching it from a coding perspective, if you already code, is a really good way to approach it. I was already fluent in Python when I started doing this, and it's taken me about a month and a half, 2 months to get to the point where I don't have to write things in Python first to then recreate them in Bifrost. So yeah, let's just quickly go through that logic again, and I'll let you go, because this really is just an introduction to visual coding. I hope to do more videos of it. I'm making like a list of post-it notes all over my room, my recording office, which I know kind of makes me sound like I'm talking in the bottom of a tin bath. But I'm making a great big list of videos to do, and if you have any suggestions, all 16 of you at this point, hi. If you have any suggestions, please leave me a comment or find me on the Slack channel or whatever you need to do. So let's just really quickly go through what we did. We talked a lot about coding, and we talked about logic, or the beginnings of logic, and this is introducing the AND statement. So I was faced with a situation where I couldn't compare two vectors, and I needed to compare two vectors. So I went straight away and I made myself a custom node. Here we are, custom node vector is equal. In here, I took in my two vectors. I converted them into floating points, so I got their elements, their x, y, and z. Oh no, I'm from New Zealand and I live in Canada, so x, y, and z coordinates. I got both of those. So these are the x coordinates, the y coordinates, and the z coordinates for both vectors. That's vector 1, that's vector 2. And then I went straight into comparing them. I said, you know, are both the x's equal? So from this x and this x, do they equal each other? Because the equal node works with floating points. That's what it's for. Same with the y. So are these two y values equal to each other? And the same with the z. Are the two z values equal to each other? I then did the first bit of logic, which is this. I've renamed it now, but this is an AND. So this is basically saying, if this is true and this is true, then this is true. So this is saying, are the x's equal and the y's equal? Yes? Great. It comes out as true. No? It comes out as false. The next one, we just did that again. That's another AND node where we said, okay, so we have the result from the x's and y's. How about the z's as well? Are the z's equal? So what this entire graph tells us is that if the x's are equal, and this output is true, and the y's are equal, this output is true, this is the AND node, and the z's are equal, this output is true. So if all three of these are true, then we output true. If one of these, just one, is false, this will be false. So I hope that's a good introduction to logic and programming. A little bit waffly on this one, and we didn't do anything visually cool really. We just had spheres and cubes. But the introduction of logic into computer graphics or 3D graphics or whatever you want to call it these days. I'm old, so I call it computer graphics. The introduction of logic into computer graphics, yeah, is huge. It's a game changer for everything. It's what allows us to do things like we did in the rays video, where we said, like, hey, where's this ray intersecting this surface? That's at the bottom of it. That is all just coding logic. And I hope that's helped, and I'll see you next time.